And for this, four types of machine, correspondingly four types of languages, correspondingly four types of grammar. Okay, so till last class, what we have studied or what we have seen, right? It's about this first mission. So from today onwards, right, we'll be beginning the second mission. For the time being, let me just name the second mission as M2, and then the corresponding language as L2, and then the corresponding grammar as G2. Okay, and then one more point I would like to add is here. For the previous discussion about this first type of machine, first type of language, then first type of grammar, what I did, I have started explanation from the machine part, and then the grammar, and then the corresponding language. But reverse will happen in the case of second machine. So for the second machine, right? Second machine, I'll start from this grammar first. So today's topic, right, what we're going to discuss is this second type of grammar. The second type of grammar, right, the name is context-free grammar. Okay, we're going to start from the grammar and then we'll let you continue. I'll close by machine. Okay, so the name of the second type of grammar is known as context-free grammar. I have replaced my CPU and then I have uninstalled and installed the things again. But I don't know, something is, I'm stuck with my writing pad. I don't know. I just tried to rectify it, but I can't. Please bear with me in between if you cannot move it properly also. The second type is known as context-free grammar. Okay, and then again, I have already mentioned that mathematical definition of a grammar is represented by NTPS. We have already seen in the case of regular grammar also. And then all the types of grammar will differ based on this production rules. Okay, so let me start with this context-free grammar. Now the and, no need to explain, this is a set of non-terminal, T is the set of terminal, S is the start symbol, and then the production rule for this particular context-free grammar is and replaceable by union of non-terminal and terminal twin closure. It means epsilon also supported, okay? You might be confused a bit. Let me write like this, and then let me take the example as it is. And then while I'll be informing you the important parts or the certain abstract of the contents of the chapter, but my suggestion is please do read the textbook. Okay, certain things are there. You'll be getting brief knowledge from the textbook also. So please read the textbook also, because in get perspective, this paper is very important. If you want to write for GATE exam and all, this is very important, okay, this paper. So now let me just take an example straightly. Example, I'll just construct a context-free grammar, okay. So G is equal to, I'm going to have none, okay, I'm going to use two non-terminal. I'm taking one, simpler example, and then this is set of terminal A comma B, and then P, let me just write like this, start symbol, this one, okay. Now P, let me write P as the production symbol, terminal, then this, then A, then A, E, epsilon. Okay. Now let me number this one as 1, 2, 3, or this could be or I guess by this time you should be familiar with writing grammar, regular grammar and all. Now see here, I've taken a grammar. I don't know whether it's a context-free grammar or not. I'm going to check whether this is context as per this particular production rules. For simplicity purpose, I have purposely selected a context-free grammar. But for the time being, let me just assume that whatever the grammar written in here, right? I don't know whether it's context-free or not. Okay. So now, as per see, am I writing it? It's I'm facing some problem. Okay, I mean, now, now see here. Yeah, I thought of using eraser and then do it. I've got stuck, so I'm doing it, overwriting it. Now see here, the first production rules, right? This one. Left hand side of this production rule, S is single non-terminal. As per the production rules mentioned in here, left side should have a single non-terminal, hence this is single non-terminal. And then what about the right side? Right side should be a combination of non-terminal and terminal, and then clean closure. Let me explain about this clean closure symbol later on, okay? So now the right hand side of this production rules consist of both non-terminal and terminal, hence it belongs to context-free grammar. So production rule number one, it's a context-free grammar production rule. And then what about the second one? It's similar to one, so no need to check. And then now what about the third production rule? The third production rules, right? Left-hand side consists of single non-terminal and the right-hand side consists of empty. I mean, this is epsilon, right? Now the production rules supports a non-terminal, and then this one means this is included. When I say this one means this starts from this, like that. Okay, so that's clean closure. Now this is supported. Now this is the given grammar is context-free grammar. Now let me derive some string using this particular grammar. When we are about to derive something, we should always start from start symbol S. So let me start from this. I'm using production rule number one. And then next, I'm going to use, I can use either, production rule number two or three. So let me just use production rule number two. A, B, B. This is production rule number two. Next, let me just use epsilon, BB, this three. This could be written as AABB. Okay. Now, not only this, we can derive many more string, like we could derive AB, then we could derive AABB, then we could derive AAABBB, we could derive then AAAABBBB, we could derive. Okay, using this grammar, we could derive such kind of string. Hence, what will happen? The language is nothing but the collection of string. So the language which will be derived using this particular grammar will be a to the power n, b to the power n, where n is greater than or equal to 1. Okay, this is the language. Got it? So practice is the only tool how we are able to understand the languages or not. Okay. Now see here, the given grammar is the context-free grammar, and the language derived from this particular grammar is known as context-free language. Okay, this is one example. Now let me take another example. Let me take another example. Example number 2. Now, construct the grammar for A plus B, this one. Okay, construct the context-free grammar. Construct the context-free for this regular expression. How to construct a context-free grammar for the given regular expression. Now, before we start with the initialization of grammar, like how many non-terminal or whatever, let me just try to understand this regular expression first. Now, what are the string possible which could be expressed with the given regular expressions are, let me just write it. Epsilon is possible. A plus B is nothing but A or B. A or B. Maybe I can select single A, or maybe I can select single B. Then maybe I can have a combination of A and B, like A, B. Or maybe I can have only double B, B, or maybe A, A. I mean, the string combination of A, B. Okay. This is the required L for this. Now I'm going to derive a grammar. While deriving a grammar, right, you need not derive a grammar which could write only this A and B alone, or maybe only A, B alone, like that. Okay. The context-free grammar which you're going to generate, right, should able to derive the whole language. Okay. Now let me just, how many terminal and non-terminal, it's up to us. Let me just start with something. Okay, let me have A, S. It's not that you have to use more than one non-terminal. It's up to us. Okay, by start symbol itself, you can complete the. What to say. You can complete the grammar itself also. Okay. Now suppose, oh, by mistake I have just written AS. Let it be. So first one, let me just try. It's epsilon. Okay, starting itself, we cannot write epsilon first. So let me. We are just writing. What to say, a derivable one. Okay, a derivable one. So I'm just starting from AS, and then next one is BS. I'm starting, and then next one is A. Then next one is B. Then next one is this. Okay, now let me just try to derive. I don't know whether it's complete or not. I've just assumed some values and then I've just written here. So now let me just try to derive this one from this one. Now, this is 1, 2, 3, 4, 5. Now, epsilon could be derived from the given context-free grammar using production rule number 5. Now, what about A? Can I able to derive this? Yes, I can derive A from the given context-free grammar using production rule number 3. Now, what about B? I can derive B from the given context-free grammar using the production rule number 4. Then what about AB? AB, let me just try. This is AB, it starts with A, so let me just select. This is AS, this is using production rule number 1. Now I just want to derive AB, hence let me just select this using production rule number 4. Now next one is, I just want to derive BB. So it starts with B, so let me select production rule number 2, and then BB production rule number 4. Now next one is AA. What about AA? Let me just start with AS using production rule number 1, and then AA using production rule number 3. Now let me just take again ABA like that. Okay, can I able to derive ABA using this particular context-free grammar? It starts with A, so let me just take AS using 1. Next one is B. Next one is B, so ABS using production rule number 2. Next one is ABA, so ABA using production rule number 3. Okay, so I guess my grammar is complete. The question being asked is construct the context-free grammar for the given regular expression. I should not write the context-free grammar in this manner. Okay, if in exam, if I ask a proper question like construct a context-free grammar for a given language or maybe a regular expression, then I should specifically specify all the non-terminals, terminal, production, then start symbol like that very clearly. So now let me just write the required context-free grammar for the given regular expression is is G is equal to, in my case, N is S alone. Then T is A comma B comma epsilon. The next one is P comma S, this one, where P is the. Now one more thing, I'm using only one single non-terminal, and then I've listed like this. Why I have numbered like this means when I apply that certain production rules, I just want to call with that number. That's why I'm using this one. So I'm going to use. I'm not going to list the production in this manner. Okay, I'll be using that sort format. A S B S A B epsilon. This is one notation is there, Beckers-Nor form. Okay, this notation I'm using for writing this grammar like this. This is the required context-free grammar for the given regular expression. Okay, regarding this Beckers-Nor form, please go through by yourself. It's not that hard. It's not that hard. This is the way I'm writing it here with this slash and all. This is known as Beckers-Nor form. That's it. Okay. Now I don't know whether I should end it here or maybe I'll just continue. Okay, let me take another example. No, example I guess enough. Okay, you just do it by yourself. Uh, Now let me introduce another term. Let me take one last example. Okay, one last example. Let me consider. Please practice more. Okay. Consider one language. Consider consider one language. L is equal to WCW to the power R, where W belongs to A comma B, clean closer, this one. So now let me explain this. What do we mean by the language? I'm going to construct, the question is we are going to construct a context-free grammar for this given language. Now, in order to construct the context-free grammar for this particular given language, let me just explain this language first. The language, W is representing string by default, but in our example, W is a combination of A, B, and then epsilon is also included, it means. Now, let me take one example. This is reverse, okay? So, A, B, C, this is W. This is W. Then the reverse of W is BA. Got it? Now let me check for another ABB. This is W. This is C. And then the reverse of this W is BBA. Okay. This is the concept of this particular language. Now I need to construct. I need to design a context-free grammar for this language. So let me just try. Okay, let me just try. Before I try regarding this language, let me construct what are the string possible with this one. A, C, A is possible. B, C, B is possible. A, B, C, B, A is possible. A, B, B, C, B, B, A is possible. Like that. Okay. And then one more thing, C is also possible. C is also possible because this is a clean closure. So instead of A, B, we could have considered epsilon C, epsilon like that. So in that case, this will become C. Okay, these are the strings. These are the strings which could be generated using this particular language. Now let me try to construct a grammar. Let me try to construct a grammar. S just check. Start from B, then A. It starts from B, then A. No. You might be thinking how easily I'm doing like this. Practice, okay? Practice is the only way. I'm just trying the minimum length string first. Okay, I'm just trying the minimum length string first. So in my case, it is C. C is the string which is having the least length. So from this, I can derive C. And then next one, and then next one, ACA. ACA. Okay, ACA. I mean, S we could replace by C, so there comes the this one. And then what else? BCB. BSB. Instead of S, I could have insert this one. And then what else? And then I can have this I can generate, this I can generate, this I can derive. And then what about A, B, P, A, B? What about A, this one? It starts from A. So let me have this one. Let me have AB. These are new non-terminal I'm introducing. Okay. My target is to try to generate A, B, C, B, A. So for that, B, A, or else A, B, A, B, B. Now B could be replaced by A, B, B. Then B could be replaced by B, S. Then B could be replaced by A. Okay, don't worry, I'll just explain. Then A could be replaced by B. Oh, again I'm stuck. A, 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 S, A, A. Okay, now I don't know, I'm just using this. Let me just try, okay? Let me just try to derive C from this particular production rule. Yes, I can able to derive C. Next, S. What about ACA? What about ACA? Yes, ASA. From this again, ACA. Okay. Now I'm just trying to number this production rule number 5, 6. In exam, you please number the production rules and then call for it. Okay, so that it will be easy for me correcting the papers now. Now this one, I don't know which one I've used. 2 I have used, and then this one I have used. Now what about BCA? Nothing wrong in that one. So let me just try to derive this. A, B, B, C, B, B, A. A, B, B, C, B, B, A. Let me just try. Don't be confused. This is very interesting paper. Okay, don't be confused. This is an interesting paper. S. What is this? A, B, B, C, this one. So let me start A, S, A. What about this S? S, B, 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 this one. So let me just use, this is, I have used number 2. Next one is B, S, B, A. So this is which one? 3. Next one is, what was my target? A, B, B, C, B, B, A. So A, B, B, C, S, B, B, A. This is using 2 again. Next one is A, B, B, A, B, B, C, B, B, A. This is using, I guess I'll just rub. Don't get confused, okay? Tell you something. I'll tell you something. Don't worry. I'll just tell you something. You might be thinking that it's a little bit complex. Okay. I thought of explaining two concepts at one point. That's why it seems to be a little bit complex. Don't worry, okay? Now, let me repeat from the initial part. Given this language, I have asked you to construct a context-free grammar for that one. For that one, right? Let me let me define the grammar for that one. Let me define the grammar for that one. Don't worry, I'll just repeat it again. Scale to S A comma B comma epsilon P S, and the P R S C S, what was that? A S A S B S B, and then this is it. This is it. Okay. Now, now let me explain it. Now, for this given language, right? For this given language, I have constructed the context-free grammar like this. I have constructed the context-free grammar like this. Now, now my question is, read this Bacchus norm form by yourself, and then try to convert this example into Beckers-Nor form. By mistake, I have started, explaining that one. I have started writing the Beckers-Nor form here. I don't know. The answer itself is there, but I don't want to say anything. So I don't want to give any assignment. Also, no need to submit it to me. So for this particular language, right, the context-free grammar is here. And for the same language or whatever the example I have discussed till now, three examples I have discussed till now, for that one, right, for all the grammar, please read this Beckers-Nor form. This is a shorthand notation for context-free grammar. Please read this format, and then whatever the example I have discussed till today, three examples I have discussed. One, a simple context-free grammar like this. Second, for this particular given regular expression. Third, for this particular given language. So all these three, please try to convert the context-free grammar into Beckers-Nor form. Got it? I don't know. Some mistakes are there, because don't think that this is the answer. Okay. Don't think that for Beckers-Nor form, this is the answer. Don't think like that. Please read by yourself and then try to convert the context-free grammar into Beckers-Nor form. Okay, now let me explain another one. Let me explain another one new concept. Now see here, our target for this particular topic which we are going to study, right? We have to understand context-free grammar. We have to understand context-free grammar. And then the language generated by this grammar is known as context-free language. And the machine which is going to accept this language is known as push-down automata. Push-down automata. Okay. Or in short, this is known as PDA. In short, this is known as PDA. Now, from the given grammar, right, we know the language which could be generated using this grammar is known as context-free language. And then from this particular given grammar, right, we'll be learning how to design a push-down automata. Okay, from this given context-free grammar, we'll be learning how to design a push-down automata. But there is certain rules. We could not directly design a push-down automata from a given context-free grammar. So we need to convert this context-free grammar into normal form, You might be thinking, what do we mean by normal form? Every values, right? Like what to say? You are being provided with vegetables, and then asked by your mom or dad, somebody, to cook something using that vegetables. If you want to cook something from that particular vegetables, right, you need to cut it, you need to process it. I mean, you have to cut in a proper shape and sizes for that particular curry to be cooked. So those conversion things, right, you can consider that one as normalization form. And I mean, normalizing it. Okay, you can think of it as a normalizing something. So this context-free grammar, right, will be converting this particular grammar into a form which is known as normal form. From here, we can directly design a push-down automata. Okay, so there are two normal forms. So we'll be learning those two normal forms. And then one more important point. before we convert a context-free grammar to the normal form strictly, right, we need to do some pre-processing. We need to do some pre-processing. We need to do some pre-processing. So after performing that pre-processing, right, we'll convert this particular context, pre-processed context-free grammar into the normal form. And then there are two types of normal form. First one is known as CNF. Okay, I'm not going to talk about the brief name of this CNF. What is this CNF and all? I'm just mentioning it. And the second one is known as GNF. Okay, so now let me draw a flow chart or something in a very short way. Given a CFG, my target is to design a push-down automata for this particular CFG. So we cannot design it directly. So what we will do is we will perform some. So from this, we'll do some pre-processing, and then after that, we'll convert this to CNF. After this, we will convert this to GNF. One and only we have in this particular format, then only we can directly design a push-down automata. Okay, so from tomorrow onwards, right, we're going to start this procedure. So purposely I've written like this. So tomorrow you should not ask why this is happening, why you are doing like this. Don't raise any question. That's why I've written this one. Okay, got the point. So today, purposely, I have not teach in a heavy portion because please go back in the textbook. There are certain examples. Okay, there are certain examples given a regular expression. Write the context-free grammar for this. Certain examples are there. I don't know whether you guys are going to practice it or not. If you're going to practice it, you are the one who's going to have that knowledge. If you're not going to practice it, you are the one who's going to lose it. Okay, no gain, no loss for me. So please, for today, please go back and read this CFG thoroughly. The part which I have discussed, that's it. So please go back and do practice. And then Backus Nor form, you just read by yourself and convert all the context-free grammar you have, whatever you have designing into that Backus Nor form. Okay. So thank you. Tomorrow also at 11th, we are going to have the class, but I'm going to start from pre-processing part. Okay. Okay. Thank you, everyone.